Reconcile. So I'll let you take it away, Scott.
Should have called it something positive, I guess, but this is what came to my mind. Who am I? I'm Scott Nichols. I've been in and around the industry for a bit, Ride Games and Google, and I've been working, so I cut my cloud native teeth on Service Catalog and then Knative, learned a bunch in Knative, and I've now seen a lot of reconcilers out in the industry, and so this talk is really about helping explain the things that level set good operators, reconcilers, controllers in the industry. Like, this is what you need to do. And then we're going to go over some foot guns that I've found all the way. It's not comprehensive. This is not a how to get started talk. This is more like how to judge what you see if you're evaluating something, or how to judge your own project a bit. If you don't want to sit through the talk, I made a slide that you can read, and then you can walk away. Here's what I'm advocating for. Every single CRD, no matter what it does, needs a status.conditions, and inside that struct, it has to have these fields, but the most important thing is that it has a status type, observed generation, and the condition type needs to be ready or succeeded, one of those two. You can have a bunch of other things, but the top level one needs to be either ready or succeeded. Okay? Sorry, the ready is something that continues forever. Succeeded is something that finishes. I think this is a cute little definition of what reconcile means. Right? If you ask Webster, it's to settle a disagreement, right? And how does this apply to declarative APIs? Well, declarative APIs in Kubernetes open the door to this disagreement. You have the spec says one thing, the world says another thing. We have examples of declarative APIs all over. My favorite one is the thermostat, where you say, dear thermostat, I would like the temperature to be 70 or 68 degrees. And then the thermometers, or the thermostat's job is to measure the environment, understand all of the operational parameters for your particular HVAC system, and adjust the environment to match what it's been asked to do, right? I declare I would like my room to be 68 degrees, and depending on what it actually measures, it adjusts. If you've read Joe Beta's book, his example is table for two, please. You walk into a restaurant, you say table for two, and you don't describe what is on the table or where the table is, or you get an available table that meets your capacity. We've heard a lot that Kubernetes is a platform to develop platforms, and this is true. And if we look at the CNC landscape, this is not the whole thing, this is just things inside the CNCF. A bunch of these things make custom resource definitions, and they provide them for you to use their SaaS-like provider, or provision things, or do whatever interesting thing that they're trying to solve. But I've seen some skeletons, or whatever the phrase is. So let's just take a quick tour of a resource. This happens to be a core Kubernetes resource, the replica set. So, right, we have the spec, it's the thing you asked for. We have the status, which is the opportunity for the controller to tell you what it did. You have the generation. Does anyone know when the generation gets bumped? I don't know, hands. So if you update anything in the spec, generation will get updated. What if you update the label? Nope. Doesn't do it. The resource version, if you dig all the way down to the very bottom of how Kubernetes is implemented, resource version is really just a monotonically incrementing number associated to a journal in etcd, right? So if you change that label, spec doesn't change, but resource version does. So if you're watching an operator, or you're watching a resource and its resource version is changing all the time, or its generation is changing all the time, that gives you a hint on where in its resource you need to look to see what is flip-flopping. And usually there's fights or there's a circular dependency or something depends on something else. And I have a couple foot guns that I want to talk about to describe how to find those things, and we'll get there. Another thing that I really want to talk about is most of you probably use Kube Builder, and I bet you've never built a reconciler the hard way. And inside, for better or worse, the Kube Builder client, or a controller runtimes client, wraps up the typed clients, the cache, the listers, the informers, all into this one kind of uniformed API. But internally, what's actually happening is there's a typed client that can talk to the API server. There's listers that they have a similar API than the client does, but it interacts with the cache directly, and it gives you cached objects. And the cache gets populated by setting up watches, populates the cache, and informers let you know when the cache gets changed, right? The work queue is usually interacted with by injections into the client cache itself. So it's, So the work queue has anyone read the work queue code? It's fascinating. It's a very good queue. And it has some advantages and some disadvantages. It is a queue, just like you would expect a normal computer science queue to work. It is strongly typed, so the string that ends up in there is key. It's usually a namespace/name for namespace resources. And your job as a reconciler operator is you have to take that string and turn it into some kind of query for the resource. Because the queue is strongly typed, the key is tied to one kind that you're trying to reconcile, right? And so there's some interesting problems where if you're trying to watch a child resource, something in the child resource has to point back to the type, the kind that you actually want to reconcile it. Usually this is like the owner reference, right? There's a metadata about the type, and so you can look for your owner reference in the owners list, and you take that key and you inject it into the work queue. The most fascinating thing about the work queue, though, is that as a worker, you can spin as many threads up as you want, but as the worker pulls a string out of that queue, and you modify it, so you update the status, because you're probably going to do that. Well, if we go back to this thing, so you store the status, it goes into the API server, that causes a watch event to happen. The lister says, oh, I've got to change it, injects it, the client puts it in the cache gets triggered, and it tells the thing that puts keys into the work queue, there's this new event, and your foo/bar thing now is added to the bottom of the work queue. It's very cool, but it does this clever thing where it'll hold open the current key, it'll add it to the bottom and hold that kind of as a pending thing, and then when you commit, say you're done, you've popped it off of the top of the queue, the pending one will get re-added back. And so it has this lossless, I can act things but add things at the same time while it's pending. It's very fancy. This interaction, though, it's one of the reasons why I always advocate for if you're writing your reconciler and you're writing your loop and you get to the point where you make a modification to the resource, you should probably exit then, right? Like sometimes you shouldn't change spec, but if you're gonna change spec, change it and then just bail and then pick it up again the next time, because you're gonna be added to the work queue again. You just do it then. Some self-inflicted footguns that I've given myself is it's when you, not necessarily with Kube Builder or controller runtime, but if you interact with clients directly, you need to make extra sure that you're using the same client and the same caches, because there are all sorts of synchronization problems that one client will get an update, but the other client doesn't get that update, and so then depending on which client you're interacting with, you see an event and then you check the state of it, and it doesn't make any sense because it's the old thing, and then that one gets updated and it's a mess. And so be very, very diligent that you're using the same caches from the same clients across all of your all of your reconcilers inside of the controller. I should side note, what is the difference between a reconciler, an operator, and a controller? Well, a reconciler, this is my loose definition, I think it's mostly agreed, but a reconciler is like an implementation, a particular thing for a particular kind, right? It's operating on Scott's object. Controller is the thing that helps you set up all of the other clients, and it holds the reconciler. You can have more than one reconciler per controller. A controller I think of is more like it's the thing that is running, it's the entry point to the pod that's running your set of reconcilers. And an operator is a very clever marketing term that CoreOS made to make it more consumable. So another thing that I see all the time is that resource models, so I make a CRD, it's a cool database, and it has a bunch of other pieces that it makes because I delegate my responsibilities of making or orchestrating the architecture of the thing that I'm building. It sort of fans out, and as you're building up that resource graph, like as you're developing the model, it needs to be useful from the bottom up. I mean, take Kubernetes, for example, right? The bottom thing tends to be the pod, and the pods, I wouldn't recommend it, but you could roll your own thing that uses pods, and it's useful. You could also roll your own thing that uses replica sets, and that piece is still useful, and it leverages pods, and on and on and on, all the way up that graph, right? And often what I see is that because it takes a lot of work to duplicate a bunch of data down, think about like the pod template spec is a bunch of data, and then the pod gets all that same data. But the graph, the model wouldn't work if pods reference the template in the object that they were created from, because this thing could change, and before the pod has a chance to either reject that or whatever, it shouldn't reference, right? Just do the hard work of copying that down. It also breaks that directional DAG sense, where now the pod, I can't make a pod without having the template of a parent object there too, right? And there's other examples where there's references to other things, and it makes it really difficult to reuse that bottom layer. So at the very bottom of your resource graph, it's very not opinionated. And as you go up that graph, it becomes more and more opinionated and maybe less verbose, right? But the bottom, verbose and opinionated. Or sorry, not opinionated. Just to level check, right? Annotations and labels, very useful. I think of annotations as kind of like strategy selectors for the reconcilers that you're using. Think like, I have a thing, but I want to use the next generation business logic in this implementation, and I want to test it out. One way to do that, to kind of A/B test the data inside your CRD, is you can add an annotation that says, I want to do the next thing. I want to try that out. I want to A/B test some logic that I have. And so in your controller code, you can look for that annotation and make an internal decision. It doesn't change the API, and you don't have to deal with backporting and all that stuff. And more or less, annotations could be ignored by the implementation of that controller, right? Labels are mostly used for filtering and identifying things. So, yeah. Okay. So, I already TLDR'd this, but the general shape of a required status is status.conditions and a little array of stuff. The old style was an status.observe generation, but this changed to have observe generation inside of the condition in the conditions list, because when we decided to do, what is it called? Managed fields, right? Manage fields is this feature where I can have my spec and I can have a controller or an owner of that can mutate the spec or reconcile different pieces of the status. Well, if two controllers want to be able, or two reconcilers want to report back what they did, the status will be sliced up into you own this and you own this, but the conditions still need to report the other controller have done this work, and I did the work and I observed this generation, and so it reports back into conditions. It makes it a little more complicated because you have to, as the owning controller of the condition of either ready or succeeded, has to then go and raster back through the list and check for up-to-date generations from the other controllers. So it's complicated. I wouldn't really recommend doing that, and you better have a really good reason to split the reconciliation like that. It's probably better to make other resources and have single controllers. I drew this diagram for a different talk, but I think it's interesting for people to see kind of the flows on what the API server does for its lifecycle and webhook checks, right? So the red things are built-in things that the API server does, and the blue things are things that you interact with the cluster with. It's your webhooks, it's that kind of stuff, right? It's all your hooks. So just be aware, this is what's happening when you're writing your webhooks. And just because you're defaulting and validation webhook pass doesn't mean that it actually stores, and they could get called again. So make sure that you're not actually mutating the state of the world inside of your webhooks directly. Okay. Conditions. Somebody was asking me, how do I think about conditions? And in my head, conditions are kind of this flat DAG where you have this top, I call it the top level condition. It's ready or succeeded. And then every other subcondition is kind of a wrapper around sections of logic that you've baked into your operator or your controller or your reconciler. And it's like this thing happened and it was either successful or not, right? And your code is compiled of several of these. Don't do too many because it gets a little noisy. Don't do too few because it's not enough information for me to debug why the thing is not working, right? Because I'm telling you, you have to use ready or succeeded, I'm not telling you what any of these need to be. These are actually highly implementation specific for the reconciler that you've created or you're using. Should things depend on it directly? It's like depending on the implementation of the thing, the internal bits, the hidden bits of the other dependency that you're trying to observe. So my opinion is probably not unless you're deeply coupled to that other thing. So I just wanted to illustrate the point, right? So this is from Knative serving. If you want to, I don't want to explain everything. Find me in the hallway and I can show you Knative reconcilers, but it's not the same as, can you read this? Let me zoom in. So that configurations ready condition, right? So we'll zoom in. It does this block of code, and then it determines, should I mark it complete or should I mark it no, right? We have this pattern in Knative where things are mark methods, where you can mark it true or false or unknown, and then we also have propagate, where we don't know exactly what it's gonna turn it into, but we're gonna delegate that responsibility for the code that owns how to translate config.status, which is a child resource, into the condition for configurations ready. I should say one other thing. Conditions can be true, unknown, or false. True means that whatever that condition represents, it's good. Everything's fine. Unknown means I'm working on it. Maybe I actually have a slide. And false means, I do have a slide. It's coming next, so ignore me. Okay, so routes ready, right? Same thing, right? So we zoom in, and there's we do some logic. This whole chunk of code does some logic, and in this case, serving is really just creating two child resources. So we're just comparing the state of this in this case, the route, what's going on. And it's either not ready or I want to propagate it up into have information. The whole point of these subconditions, remember though, is to tell the human what the heck is happening. So that message needs to be as useful as possible for the human, and if you want to depend on the implementation, then you start to know about what the code of the reason is inside of the condition. Right. So, like I said, true means everything's fine. Unknown means it's not what you asked for, but I'm working on it. I'm not stuck. And false means I need an adult. Like something fundamentally needs to change in the cluster before this thing's going to flip-flop. It either means that I'm missing some nodes, or I have some invalid schema or something that got in, but it is stuck until intervention. And you could have some automation, or it's probably like some poor on-call person has to fix something. Do me a favor. So in doing preparation for this, I did a bunch of research, and it turns out that 79% of all issues in Kubernetes are because of typos. Yeah. And I have a whole list of other facts. You should scan this code. Scan the code. Yep. So don't trust status if observed generation doesn't match generation. If you look in the little details, I have generation 4, observed generation 1. So my status is a lie. It's not what I intended. Who knows what it's doing? I don't know. I can't trust it, right? So one of the things that I see all the time is that controllers will go and redo reactions because of that lister, watcher, cache update thing. You get kicked back into your reconciliation loop and you're going, and you kind of blindly go and react to its status because you've propagated some change, but you're really reacting to probably the controller itself pushing status or a change to status into the child resource or whatever, right? And until you see generation match observed generation, which is why it's so important, you can't automate anything reliably without like sleep 15s, waiting for the next thing, right? So sorry to troll. I'll touch on events. Right? So one of the useful patterns for explaining to the humans why your thing is doing wacky things is emitting events, right? I think that events should be emitted on meaningful changes, big meaningful changes. Success path, not so much. You actually bump into getting API quota back off. You're going to emit too many things to the API server, and you're going to get delayed, and you won't be able to actually log the important things when you bump into an error, and some other things. Logs, this is for the context of writing controllers, right? Keep the happy path as quiet as possible, because we don't really care that everything's working because it's working, right? We want to know when it doesn't work, and when it doesn't work, add some context about what was it actually doing so that we can go and investigate an instance of a CR inside the cluster and see if it has events, or if it has conditions, or if it has children, or if it exists at all. Metrics that matter. Well, I'm sorry, I got to speed up. Work queue depth, right? How busy is my reconciler? Duration of reconciliation. How lag is it going to get? Is it ever going to catch up? And know the number of workers that's pulling work out of that queue. So the foot guns is my favorite part. Again, ignoring observed generation, biggest foot gun I've seen. You do work without understanding that the world is being reported accurately. One that we bumped into in Knative a bunch is adding very helpful mutation webhooks that simplify the input. So a user types in 60 minutes, and the webhook will turn it into 1 hour. Same value, right? But then the controller, maybe a controller spits it out, and then we see that it's a change, and then we fight. We fight forever, and then we get observed generation over 9,000. It's probably more like 40,000, but referencing spec fields. So my opinion is that if you think that anything is ever going to be an input to something else downstream, always propagate it into the status. Just trust the status, right? Referencing things in a spec of something else, I think is an anti-pattern, actually. It also gives the controller a chance to resolve that, right? That's when you convert that 60 minutes into 1 hour. If that's your preferred way, something downstream is going to consume that. It's in the status. I talked about 2 caches, right? Just use 1 cache. It'll simplify your life. Actually, we bumped into a different one. You don't get this with controller runtime, but the typed clients and the dynamic client also have their own independent caches. And so when you're doing duck typing, and if you search for duck typing, there's a bunch of talks. Though the events for changes come in at different times, and we would see a change, and then we'd look in the typed cache, and it wouldn't be there, and then the reconciler would get confused, and then have to wait for the next update. Very confusing. Try to always kind of use the same client that you're interacting through. So what's missing? Well, I had to write a bunch of weird code inside of Knative to help make that DAG controller condition thing. So subcondition manager is missing kind of in the wild. Controller runtime doesn't have this thing. And there's a whole list. So I have a few minutes. I would like to enable questions if anyone has a question. But yeah, duck typing support is big. If you don't know what duck typing is, it's search for polymorphic reconcilers. It's a talk we did a couple years ago. You can do some things, but not all the things that we can do in Knative. KubeBuilder is getting better. Somebody introduced something like reconcile kind, but the whole point of reconcile kind is that the first phase of a reconciliation is you get that string of a key that represents an object somewhere, and you have to load it up and make sure that you duplicate it so that you don't mutate the cache, because the cache gives you the real copy, which is another foot gun that's fun. So you have to deep copy it, and then you can mutate it, and then you hopefully throw it away or do some update or something. So reconcile kind turns the string into a real object clone on your behalf, and then that's the entry point to the reconciliation. Yeah, that's all I have. Thank you for listening.
Great. We definitely have time for a few questions.
Scott, thank you very much for this. This is one of the presentations that I would like to have the link of the recording for whenever I'm writing a controller to watch at, because most of the time, probably I didn't got all the details, but when I'm writing a controller, I will say, okay, that's the reason why Scott was saying that. That's super interesting. So again, like coming from the Knative background, I know that in Knative we are not using controller runtime. So what are the main things that pushed you not to use that and just create your own kind of like caches and different mechanisms there?
So the big Knative's controller come from what Kube had as an example controller framework, and it basically was, a reconcile method with the string, and then how to set the controllers up and type clients and all this stuff. And KubeBuilder comes in and says, well, it's actually really difficult to set those listers and watchers up correctly. It's really difficult to use typed clients. So we're going to wrap some of that stuff. And then there's this Fluent Builder thing to help set up the controller and initiate those caches. And it makes sure that you can't mix and match caches and things like that. The other biggest thing is around the life cycle of the resource, right? So KubeBuilder by default has the string, and you have to turn it into an object. But if you use their client, it's not the cache version, it's a copy for you. Knative has this pre and post amble piece that we added, which is confirming that you haven't mutated the spec. We just ignore that stuff. We clear out or initialize some of the conditions that we use because we have a pattern about the manager. And then at the end, we decided that you can reconcile your kind and then return the mutated object, and the thing that called you will take a look at the condition or the status and determine if it's time to do an update on status, which means you focus on your business logic, and then the Knative side will help you submit that to the Kube API. Controller runtime, you have to do all this on your own. And I've done a couple other talks. I think it was TGIK 145. I did a talk, and I tried to use controller runtime, and I got burned by that because I forgot that I have to do that like a farmer. And so it took me 5 minutes to remember. And
Any other questions? No? All right, great. Thank you so much. Really, really great talk.